Okay, so we're going to go ahead and do a little introduction on technology in architecture. So the world of information technology casts into question the traditional systems of techniques in architecture today. With the growth of technology, rapid prototyping has increased through scripting technology and parametric software. Some other points in history have also become shifts in technology, such as the industrial period, where there was an introduction to new materials and building technologies. Then the development of Taylorism, which was introduced in the 20th century, where it helped production become efficient in which to aim for maximum job fragmentation to minimize skill requirements and job learning time. To even Le Corbusier, where he questioned the meaning of architecture as a rigorous function into the house as a machine for living. Even if changes have taken place and techniques and disciplines have become more interdependent, the general inquiry remains embedded in the relationship between scientific technical activities and the world of both practice and meaning in architecture. Which brings me to my first question. How do these changes in architectural process contribute or take away from the idea of understanding or meaning in the architectural design?
I mean, what you probably could do is do a step back maybe in the 19th century. And as you had said clearly before, that the paradigm shift is happening also right now, right? So you have at one point you have the change from the pre-industrial age, right, to the industrial age, to mechanical processes, yeah, which had an enormous effect on how architecture was thought about, conceived, practiced, and built, right? From, let's say, from the 1850s onwards, almost the next 150 years. Yeah? So it had a cultural impact, it had an economical impact, social impact. It had made changes across any level. Yeah? And what it did, it actually created a kind of a crisis at that time, to which architects had to respond. Yeah? And so that's today actually not much different. Yeah? There's kind of similarities, as you have said. So we have a new paradigm shift, which started probably with the invention of the personal computer in 76, yeah? And then with the mass distribution of personal computation from the 80s onwards. Yeah? And suddenly we have tools available across the board that change the way how we think about architecture. Yeah? And certainly does adds meaning to architecture. Yeah? Because in the end, it's it's technology. It's a different way how you operate. If it expands the meaning, I'm not so sure about that. And I think it for sure develops maybe a new perception about space, for example, could be one. It could be ways of how you design, how you operate. So in that sense, I think it opens up an enormous potential. And if you maybe want to be critical about it, I think because you sent us a statement by Vittorio Grigatti, which is an architect. I don't know if all of you know Vittorio Grigatti. Is an Italian architect, born around the 1920s. So by now he's kind of old generation architect, and of course that generation sees it completely different. Yeah, I mean, they maybe see actually the implementation, particularly in the statement that you sent us, they see the implementation of technology in a more phobic way. Yeah, they kind of see it as they don't understand it at all. So I mean, there's this kind of generation conflict as well. Yeah. So I don't know how you want to respond. I think that it's most about the perception of architecture. The way how we design it, yeah, today is completely different than how we thought about it and designed it 150 years ago.
I think the question is a little bit broad question, right? Technology in architecture. So are we talking about building technologies? Are we talking about, but you also mentioned in a way, it's like rapid prototyping or scripting ideas. It's more into, it's narrowed down into certain specific areas, right? So like Professor Pongas mentioned, I mean, this is the time we changing very rapidly. Not only that prototyping, but it's a changing time because of, like you mentioned, personal computers. Computer actually developed in 1950s, but after IBM making the chip, Intel making the chip number, which is 384, that came out as 1980s. And that becomes really personal computer ages. And that time is the one actually architects started picking up the computer-aided design ideas. And that time it was more likely a drafting tool. It's an aiding tool rather than actually designing tool. But it also moved very fast into another technological kind of integration or invention, which is the internet or information ages. That happens from 1990s, but right now it's somehow rapidly changing, right? And like a social structure is also changing, like a Facebooks or Twitters. I mean, 3 years ago, 4 years ago, you don't even have that, right? And like three-dimensional printing ideas that came in at the end of 1990s, but right now we start having 3D printers, right? And we're talking about rapid prototyping. And now, with this speeding up of certain things, we start to questioning about the value about these speedings, value about these new possibilities. So this is also changing time. Some of the architects or designers start questioning about rapid prototyping, fabrication, and scripting is all possibilities. So we start to know what we can do, but what's the actual value about these things, right? Once Stan Allen is talking about very interesting articles. It's called Terminal Velocities. He was mentioning about the very hot summer in New York. I think some of you read that. Hot summer day in New York. Cats are falling. We don't know why. But cats are falling from the building. If the cat falling within, let's say, 3 stories below, they're okay. But after it reaches the 3rd floor, 4th floor, and 5th floor, the survival rate is kind of dropping down. But if cat is falling from the 7th floor, then actually it's much more possibly it can survive, because cats start to twisting their bodies and then completely relaxing it and start to developing the resiliences that actually landed or absorb the impact after they hit the ground. But when it reaches to 15 floors, then it's hopeless. So Stan Allen is talking about, it's not about the distance, right? It's not about, it's a 2-story up or 6-story up or 15-story up, but it's also about the speed. And he's talking about the speed in a way, a metabolic speed, how we live, how we perceive, how we eat, how we're sleeping and then thinking, and technological speed, which is computer speed. So computer technological speed is sometimes much faster than it's very hard to perceive as a human being. And he's talking about, in a way, how we actually taking that advantages about technological speed start to weaving into our metabolic or biological speed, and then we can actually see things much clearly. So I think that's an interesting argument. Like in a design studio, you guys are using like a lot of digital tools, right? And sometimes some digital kind of tool, it let you allow certain things in a very fast manner. And at that point, you start to losing actually perceiving certain things or evaluating certain things. So it becomes a very interesting aspect for the design studio kind of professors, like writing a couple of scripting, and then it starts generating certain aspects of the designs. Then we start to losing the capabilities about, not the capabilities or possibilities about the technologies, but capabilities or possibilities about how we decide or how we see the values. And then silence.
Well, can't really comment about, hold it like you are. I can't really comment on computers in the 70s or 80s. These guys.
I read about that.
Me too.
I wasn't participating at that time. But I mean, Christian, you mentioned about the process is potentially different between maybe the process of how we practice architecture in the early maybe 1900s between what we do now. I think to some point, yeah, but to some point, I don't think so. I mean, I think it's still pretty much the same, right? I mean, I think the technology has allowed us to explore maybe other facets of maybe like material, and it's allowed us to engage material and engage other areas that maybe we weren't doing before. You know, we're no longer maybe just a CAD monkey anymore, but we have a certain freedom. You have a certain, I mean, especially someone for like me in my research and my investigation, you know, I really pursue working with the machine, exploring with material. What can I do to material? How can I use the machine to, you know, cut the material differently so it performs differently? So I try to engage in the process of changing or sort of inserting myself into how I use the machine. So it's not, you know, typically a CNC machine, you know, you got guys, if you've ever been in a fab shop, that are just 2D cutting all over the place, right? So how do I insert myself into that process now and somehow go into the software and change something? How do I manipulate the cutting pattern? So how do I potentially say a piece of plywood, how do I cut a dash pattern in that so that I can take a flat sheet of plywood and curve it, potentially? I mean, these are some of the things that we are, I think technology is allowing us to really investigate, is how we approach or how we potentially use a different process in our process. I don't know if you agree. But I think it's allowing us to explore other things now as architects. But to talk about speed and rapid prototyping, I mean, what's interesting is also the economics of these things, I think, and how, like, say in 3D printing, you know, what 5-6 years ago was incredibly expensive to maybe own one of these machines. Now you can get a 3D printer for, what, $1,200, you know. And then once you kind of have this machine, you can start to use it to then produce another machine. So you start to print its components, you laser cut the formwork for it, and then you make another one. You know, you have a CNC machine, you can then use that CNC machine, and then you cut another one. So you make your own then. You see a lot of these things going on right now, I think.
I mean, that's the interesting aspect, right? The rapid prototyping, and you're talking about like fabrication and tooling of certain things.
Exactly. Yeah.
So it gives you a great amount of possibilities. The architects or designers not become a just design person, but actually deals with the specific manufacturing process. So it's somehow giving you the position back, like old time, like a Renaissance man. Actually, he designs and builds, and then actually live together, right? So after that certain period, industry start to divide into the certain directions, right? Architect becomes a designer, and then there's the fabricators, and there's the contractors. Now, technological side somehow make us possible. Designer is not only the designer, but also the fabricators, but also to understand the tool and then trying to innovate certain aspects. And price goes down because it's a mass production ideas. And I think that also goes into very interesting connection with the modernity, modernism ideas, and then currently somehow in a very chaotic ideas. Modernism was like, I'm not historian, but it's about the mass productions and standardization, one aspect.
Yeah, now we can mass customize.
That's the direction. Yeah. I mean, it's mass customizing, and also information technology make us possible, like individualize us.
Yeah, this sort of this one size fits all model is no longer applicable anymore. I mean, we don't have to be applied to that. I mean, we can all have something unique and interesting, and it be fabricated or made for the same price. I mean, in theory.
In theory,
yeah.
Similar price.
I mean, but having unique, I mean, that's the kind of freedom that I think we have now, is that if we want to have, 5,000 unique panels on a building, we can do it in relatively, somewhat inexpensive, compared to maybe this was probably impossible, 20, 30 years ago.
At that time.
Well, at that time, yeah, it was impossible. I mean, now you look at maybe some of these incredibly complicated panel buildings. Maybe they have 10,000 panels. Gary building.
I mean, to a certain extent, we have to say that actually architecture went a long way, maybe in the 20th century. Do you guys hear me? No? Hello? Okay. I think that we went probably a long way in the 20th century. I mean, you see here the building of the Bauhaus. And it has actually a precedent, which is by Peter Behrens, the AEG Turbinenfabrik, several years earlier. And that was actually an enormous shift in the architectural design, because before, architecture went by types. So each building had a very specific typology. You did a church, you did a school or a hospital or whatever, residential building. And you had to follow a certain method. And with the change of the early 20th century, as we see here, suddenly we don't work anymore by typology, but actually by style, specific style and standards, right? So what we see here is you have a large glass facade, which was previously unthinkable. And if you look at the previous president of Behrens, which was, so to say, the father of Gropius and Adolf Meyer when they did building, it was more about brick. So there was, even then, was actually a strong change. How could we do that? Because certainly, as we had just said before, industrial manufacturing and fabrication allowed the production of certain materials easily, glass and steel, and you could compartmentalize windows, and you could make a lot of them. And so what we see here is simple boxes. We have a flat roof, and we have window bands. So there are certain characteristics that every building had to have. Right? Unfortunately, it ended up in a kind of a dogma. Most buildings, if they wanted to be modern, had to follow a certain style. right? Now, today we are on a completely different plate because we don't know yet what the style is. We, like them maybe to some extent before they started. We have a lot of technology around. And we argue, yes, we can maybe mass customize, which means we can do any one of those windows different. Yeah, we have the machinery, but the economies are not yet there. Yeah, so we can do a style today that is much more individual. We can actually personalize any type of building easily. The question is where do we go with that, right? Cost is still a problem. And if anybody says we can mass customize any amount of pieces, it's really still a problem, right? We don't really can do it yet. In theory we can, yeah, but there's always a cost that is involved. So what we saw when you were in the recent lectures and also in our workshops is, or if you look around on the internet, where you have to work, like in this case, for example, right, you have either a minimum amount of details that you have to resolve, right, or you have a minimum variation on the amount of pieces that you produce. Somewhere you have to reduce. Either you say my joints are all over the same, and I vary as much as I can on the other elements, or you keep all the joints different and they produce the same pieces. I mean, there is a mathematics that you have to follow, which still constrains us today. But what I think what is maybe a very good potential in architecture is when you think about the Renaissance, when Alberti introduced the perspectival drawings, right? He gave us a new tool. In the Renaissance, certainly what we could do is we could draw and design, and the master builder was able at that point not only to oversee everything, but actually come up with new types of drawings that explained ideas. It changed the profession. The Renaissance and Alberti and Brunelleschi, etc., changed completely the profession. What was the negative aspect of that was, because the architecture profession focused on design and to elaborate drawings, we retracted our position at that time, and we don't become any more involved into the actual construction process, and that lasted until very much recently. What happened is, over time, you had the master builder reduced himself to a pure designer, and so other figures came up, which in the 19th century we know is large developer companies, construction companies, that take away work from us. Now, what is the advantage that we can see right now is the technology, and that means what you had just said before, 3D printing, CNC milling, right, laser cutting, designing with advanced computation, understanding spatial qualities. What does it allow us? It allows us to get hands-on areas that we long have lost. Just think about the last 20 years, right? A lot was about theory in architecture. A lot was about philosophical concepts, particularly in the US. Young architects, those that are actually starting to build right now, that didn't have any chance of doing construction. Now, because through digital technology, what we can do is we close the link, and we start not only to design, to think digitally, but we start to produce digitally. We start to understand how machines operate. We get more knowledge about how industries operate, how pieces are built and fabricated, and as we start to also explore here in the college with you, is we start to understand how we cut, how we mill, right? How we 3D print. We get much more hand about understanding what the fabrication process is. And that allows us at one point maybe to have much more communication with other members in the construction business. That's, I think, in my opinion, the big leap that we are able maybe to do. Unfortunately, all three of us represent somewhat the same area. So you will not have any kind of maybe diverse opinion on that, I guess. So there's a strong potential somehow. Yeah? Now the question is, what do we do with that? Yeah? How can we elaborate it further? Where is the research area, right? I think a big question today is in architecture also. I don't know, do you have more questions, Anna Laura, or we just go on?
If you want to just elaborate a little bit more, but there are more questions.
I think another big aspect today that I'm questioning is, where is it possible to innovate? Right? If you look at across the board, not only architecture, but a very important question is, where is innovation happening, right? In any type of science. How can we innovate in architecture? Yeah, how can we change? Yeah, because on the end, even if I just have said, all right, we got the potential, we can go back into the construction process and the architect can play a more important role. He can actually do more on a building job. On the other hand, we have to say that the whole construction business is still separated in tens of trades, right? We got a lot of trade. What is the problem today is the detail is still not resolved. Why? Because we have a lot of trades in construction business, and if you see even that building, it looks seamless, right? The white one by Zaha Hadid, but it has a lot of joints. Those joints need to be resolved, but not by one contractor, but by many. We still build the same way like the Romans built, right? You go on the construction site and you deal with 10, 15, 20 different contractors, yeah? They all don't care about each other, yeah? They give a shit to each other, right? So if somebody makes a problem or a mistake, the next one just pushes on his shoulder, right? We still build the same way. We still execute architecture in the same way, yeah? So that's where the problem lies, yeah? So technology, to some extent, the more you go into maybe prefabrication, the more you go and understand how things are actually constructed, industrially produced, the more we probably get to a possibility where we can start to cross over between trades. Yeah? So that's also, I think, a good potential. Yeah.
Well, let me ask a quick question. You mentioned the Renaissance and the master builder, and a couple things came to mind. First, when the Spanish settled present-day America, they employed the Native Americans they sort of just told them, design this, and the Native Americans didn't know what they were doing. They just built what they saw. And also sort of the same thing happened with pattern books, is when they were introduced, you know, you didn't have to be specialized as an architect to do it. It told you how to build. So do you think that technology now, where it's heading, we're just, maybe the role of the architect's changing and we're becoming specialists now in these different things, in these different programs? Is technology creating specialists now that can sort of, I know Dustin mentioned the 3D printer as sort of, you know, this is what he's good at, and then you can start creating components based on that. And so is the role of the architect changing now?
We don't know yet.
Oh.
And the point is, technology, let me put this into the metaphor. I mean, there's no bad dog, but there's bad owners. Technology is somehow, in my point of view, is a neutral thing. It's depending on actually you guys how to using it. You can abuse them, and it's sometimes, you know, coming back to you. It's like you mentioned the Renaissance men and master builders, but in my point of view, with this all different kind of fabrication, development, and then building information modeling and everything, although we're not going to going back to master builder ideas. Because after a certain point, when construction or fabrication becomes fragmented and then they develop into their own directions, it's become very specialized. So at this point, if we want to kind of put everything back, it's somehow over maybe one person's capabilities. But fabrication ideas or understanding the fabrication tool or joint or tooling ideas or understanding what contractors want or engineers want somehow put you into the direction that you can actually control the process of making it. So you're not doing everything, but you oversee the whole thing, and then you specifically know how your design have to be executed. When you going into that direction, you becomes really the front runner or leader of this whole thing. But in some point, contractor tell you certain things or engineer tell you certain things, and you don't really understand what's going on, and you just accept that thing, and you changing your designs. Then you becomes a part of the just flowing water. You not become actually riding in a certain directions. And I think it's currently changing kind of paradigm ideas. So when you're looking at the kind of, I hate this word, but building information modeling ideas, we are talking about the information in the middle, and then designer, engineer, and contractor, or all of these different people with a very even distance surround these information. That's the ideal situation, what they think, and then somehow very neutral diagrams. Yeah, maybe that. But what actually we need is actually we need to bring the designer and digital model distance into much, much closer. So we are going more into the digital model. We need to go more into the information. In a way, we can actually control the process. We cannot control the engineers. We cannot control the contractors. But we need to control the process, how they're doing it. So, with that understanding, may be possible by building information model or fabrication, all these technological possibilities.
So this is what you see here is a diagram. It was put forward in Acadia 2002 conference, and that is where the Baron here, the architect, explains where he sees maybe the current state or where the future architecture will go. And imagine that in a Renaissance, in the middle would not be that simple, but there would be the master architect controlling everybody. And where we are right now, we are one among many members. Now, architecture, on the other hand, is right now a profession that is not only behind the way how we operate, but we're also behind in terms of other industries. Often when we go to technology conferences, you see a lot of references made to the automobile industry, to the aircraft industry, and to some extent they're right, because those other industries, they probably use similar tools like us. No, actually we use their tools, because we don't have a tool that is actually specifically made for architects. We actually misuse other tools, but they are much more effective and much more operative, because long time before we thought about cross-disciplinarity, or we talked about in architecture, we could actually collaborate with engineers and not just give them the drawings once the job's done. They all already long time ago started to collaborate cross-disciplinary. Why? Because an automobile has to move fast, or at least we like it fast, and airplanes have to fly, right? No building flies, no building actually has to move. Buildings are static, right? That's why we can still afford a process that is probably thousands of years old. Now, this model is somehow copied from those other industries. And what it suggests is that you have engineers, and you have suppliers, and manufacturers, and managers, and owners, and builders. All of them are somewhere around and on the same building information model. So there's somewhere information, as Kuhn previously suggested, that flows around in space, and everybody who participates takes a chunk of it and modifies it. While he modifies it, simultaneously everybody else in the same table, virtual table, sees the modifications, and based on those can actually add his own information. So like an airplane is built, Boeing is built, I don't know, in 150 countries worldwide simultaneously, engineers in every country, designers in every country. And at one point it appears. Now, I don't agree in that sense with you, Kun. I think the architect will probably no more have a control ever, right? Because the design, in my opinion, the design will happen in so many facets that the architect alone maybe will give an overall shape. But if we actually think about that model, it means that there will be somebody, he will be so specialized and so sophisticated in his design skills that he will design interiors, door handles, window frames, anything so much more better than us, and will contribute that model simultaneously. Right? Right now when you talk about what are young architects doing right now, they start in those models already. Right? The young firms right now appear because they cannot afford infrastructure, but they can afford knowledge. They have it ready and they can share it with anybody else. So what they do is they basically work online, they find collaborators, and they can actually with that do any type of size of project. And we talk about a distributive knowledge design strategy, where a lot of designers can simultaneously share an approach to a project. Pretty much like that kind of suggests. One can be an engineer, one can be an architect designer, one is a product designer, one is a facade designer, etc., 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 right? So everybody at one point will have to collaborate. So what this suggests is, if you're out to work somewhere alone, no way. You got to learn to collaborate early on, and best here in the college. Right? You got to understand how to share your knowledge and appreciate others that are better than you, and accept that into your own kind of process and strategy. So it's all about collaboration. And this might be a way, if we, and in that sense you're right, Kun, if we get a hand on that digital model, if we know how it's built, if we know how we can modify it, if we know how that model can in time simultaneously be exchanged with other people all across the globe, then we maybe are competitive. Our big, how to say, the big problem for us might be that there will be large construction companies out there, design architectural engineering companies that might be faster than us of kind of hopping onto that model and offering services that we alone as architects, even collaborating, are not yet able to provide. So you have to see the kind of enormous potential that we have in front of us. And the younger you are, in your case, the more you will probably be able to participate in that.
I mean, if we follow that model, we become the aesthetic consultant, basically. We need to go very close to that digital model. So we need to climb up and then put ourselves as close as possible as a digital model, and then looking over the whole process, how it communicates, how engineer actually, or contractor, everybody is doing. That model looks nice, the model looks ideal, but if you follow the model, believe me, we're going to be just aesthetic consultant for the whole architectural engineering and construction industries.
And then what is another problem is that if we look at the construction process right now, it is to the major part still bottom up. Right? So you collect data, pretty much like in the Renaissance, pretty much like in modernism. You collect data, you start to accumulate it, sort it, filter it, and prepare it, and then you start a kind of a linear design process. That's architecture. Right? What is the problem? You have late stage design decisions. You have clients, you have developers, you have large scale construction companies that down the road make decisions in which you are a priori not involved. Those decisions get communicated to you, and what happens is the model that you were working so hardly for weeks, months and years suddenly has to be put in the garbage because it doesn't fit anymore in the performance. Right? This was is still our process, how we operate. Right? We spend time, even if it's a IBM model, information building model, a lot of that might be not adequate to decisions later on. Okay, that's the challenge. What does it mean? It means that we have to learn that late-stage decisions, either administratively, from any person involved in the construction process, late-stage ideas of changing materials, or fabrication processes, industrial manufacturing processes, have to be available to us up front. So downstream the process, so we can put it into our design process upstream. That's a big challenge. We didn't resolve it yet. I think there's large areas of research working on that. How can we integrate late-stage design changes? How can we integrate fabrication processes early on into our design process? And that's what in other industries is already happening, because they know how sheet metal is bent. They know how to develop the curvature on sheet metal. They know construction times. They know cost. Everything is in place. They know wiring. If you look on a Boeing airplane, there came an engineer somewhere in Southeast Asia, and he puts into the airplane at the same time that it's being designed, he puts in the mechanical pipes exactly in space, located down to the millimeter. And that's the industry that we have to look for. We are not yet there, and that's the big challenge.
Yes. Okay. A question maybe geared towards the new notion of speed and sort of this intensity of speed, as well as kind of playing on construction practices, as you're talking about. We see now in multiple examples with China that during schematic phases, the SD set is submitted, and then all of a sudden you realize they're breaking ground, and foundation is being poured, and piers are being poured, and things are already on their way, and you haven't even drawn a CD set. And that's exactly, I think, in the same realm as to what you're kind of indicating. My question is potentially both because of that speed as well as that sort of example, and then we have sort of these intense experimental examples which are happening, not so different than what happened with Bucky Fuller kind of conditions before. So I'm rambling, but my question is essentially, is the speed too intense to evaluate feedbacks? Or how are feedbacks used to control value and meaning, which was brought up in the first question?
I think that's currently still kind of developing and still testing kind of ideas. Like you said, schematic design you pulled out and then start excavating site and everything. That's what AIA think is a new project delivery process, which is integrated project delivery, IPD, and that becomes a standard instead of design build process. And that's very based on the building information modeling technology, and it also changes the whole process of how we're delivering the architecture into the real world. And also it's market driven, because design and construction time shorter means much more profit for the clients. And it somehow start to developing the anxiety to the architects, because the two different speed ideas I was currently mentioning about, kind of metabolic speed and then technological speed. I think we now see the clear difference between these two. And now we see trying to figure out how to tackle these ideas. But in terms of feedback, what they think as a feedback is also the simulations. So it's pre-construction, pre-design simulations. But I'm not quite sure about that simulation does really help our like metabolic speed and an understanding about holistic architecture problems. So I mean, integrated project delivery was started at 2009 actually. It's pretty new. And they started from the California and is started moving into different states. So I think maybe within 5-6 years we start to see pros and cons.
Another question came up just right now when we were talking about, the speeding process of things and this mass production due to technology. So you're talking about how you can produce certain materials or fabrications that can be delivered into or put into a building. And then we also talked about how each building, is unique and individual within its meaning. So if you have this mass production of materials and techniques of building, how does then the building become individual or unique? Because if you have this mass production of, let's say, a certain object, you have so many of them that they're going to be placed in, many different buildings. So how can this mass production make a building unique or a design unique?
Seems is kind of an oxymoron by itself, because on the one hand, what we want is we want to have speed, so we want to actually react to market demands, and we want to build faster, more economic, and on the other hand, we have the question of individuality, which is also an expression of our time, because when we, for example, go back again to modernism, right? Then the way how products were distributed, it was like, oh yeah, this kind of laundry detergent, it washes whiter than another one. And people said, all right, let's buy this one, it's whiter than the other one. Right? Today, when we look into products, then products are so complex that in a short period of time, you can actually not communicate what the content is because it's so diversified. So everything is basically about the wrapping somehow, right? You tell a story, you sell a lifestyle. That's why it is better than something else. So the whole marketing process is much more elaborate. You sell a lifestyle. That's what it is, right? It fits basically with you. With buildings, of course, that is a different thing. Because, of course, we could, in theory, and we had that said that before, you can kind of mass customize, for example, a smart car or the Nike shoes, right? You can go online, you can change the color, you customize the product you want, and you have it sent to you directly at home. With architecture, there is ways, there's online sites, for example, where I remember also Karl Osterholz was doing the Vadio house series, so you can go online. It looks like a kind of standard building. It has kind of a type-of-cell roof, slightly curved surface on the top, and what you can do is there's a little slider. It changes the spline that defines the roof, and so kind of your building is a little bit different than your neighbors. The prices are kind of set somehow within a certain range, so the price doesn't go so much up, but in the end, it's kind of such a subtle variation. I'm not sure if it kind of really satisfies individuality to one point, right? Sure, we can, in theory we can, granted we have enough money, we can do so many customized products, 3D printed, laser cut, CNC milled, anything, to make a super individual building, but it doesn't drive down the cost yet. So what I had said before, how do you drive down the cost? You keep the individualization of the product, so building elements so small, that you still can do a large series and a subtle variation within them. And if you go to, what is that, in Miami and Florida, this is basically serial fabrication. Every house the same. Every front yard the same, and you drive along.
Well, I have a question here. First of all, a comment and then a question. I excuse Dustin because, of course, he wasn't born by then, I guess. But, guys, I heard this conversation in the early 90s, exactly what you're talking about right now. And I wonder if we're repeating the stories. We talk about speed, And that was a term that was discussed by Paul Virilio in a long time ago, like late 80s, early 90s. I mean, one of my influential books that really kind of got into me was Aesthetic of Disappearance in 1991. And then after that came The Art of the Motor and other books as well. And now he's talking about speed and politics, and he's talking about kind of speed and ground zero, and he's talking about speed and other kind of speed as well. So anyway, that is an old topic that I think was taken by new theorists, and kind of like Stan Allen maybe is kind of taking the ideas from Paul Virilio. And Paul Virilio is very related to architecture because he's been working together with Claude Parent in a lot of issues, and he worked together as well with the kind of like ruins that happened to be after the Second World War, particularly in Dunkirk and Hitler bunkers. Anyway, so my question is on speed. I heard that in the 1990s as a major topic, a major thing that was happening as well, and all this idea of technology. But then the other issue about what we're living in technology, I heard that as well when all the high-tech movement, when Norman Foster's and Nicholas Grimshaw's and all that were kind of coming out with their ideas about kind of creating the last elements of technology, new productivism, and creating kind of buildings that are unique because they have the last elements of technology. The little screw that we're going to use on that building is crafted with the last technology. Somehow they were intending to do the mass production was a big mistake for high tech because those were the most expensive buildings ever built in life. Beautiful, but very expensive. And we see the Georges Pompidou coming on 1977, 1978. So are we repeating these stories, guys? Are we repeating the history again? Maybe with a different kind of digital technology and more kind of like advanced computer technology, but I heard this, so I don't know, that's kicking me kind of a little bit. What do you think about it? Because he wasn't born by then.
History is always repeating, but in a very different degrees. But basically, it's repeating the same patterns, I believe. And like for Pompidou Center or the Norman Foster, it was somehow very popular in the time as high-tech architecture, right? And then it does have, it kind of manifested the mechanical beauty or aesthetics about it. And it also goes into the direction like metabolism architecture in Japan and the other directions. But this time, I think it also uses a different kind of tool, which is the digital technologies and then the other kind of fabrication ideas. So it's like if I kind of revisit the idea about the history is kind of repeating itself. I mean, architectural development, and then there's a glass coming in, and then there's that glass as a material becomes one technological driven factor, and it still comes in, and that goes into the different directions. So I think this digital fabrication or fabricating ideas looks maybe similar in your terms in your point of time as a technological kind of architecture on those times, but it's in the very different directions. And actually, I want to talk about your question before. It was about if everything become unique, then what is the unique thing? I think it's always the same idea. Is if parents talk to children like everybody's special, then it becomes nobody's special kind of directions. It's like, but also, I don't think that will happen in architecture, because a city, good city, great city is built on actually contingencies, based on these gaps, based on these kind of flexible ideas. And in digital fabrication or these kind of informational technology ideas, is somehow interplay between the kind of rules or very strict notions and the chances. And it somehow goes into the direction, into the predictable kind of organizational things. So in that direction, I think it will produce some unique things, but it will not cover up the whole city. And like you mentioned, there'll still be just the production and just the production of a certain design, and there's a possibility. So sometimes we call it as a digital craft. It's the new way of actually crafting or designing certain things. So I think when you start talking about the digital craft or fabrication craft, then we start to actually putting a certain values to differentiate this thing and the other things. So in that matter, we start to actually talking about the value of these new technology and aspects.
So technology is always considered something that's been really great for architecture and has helped develop it significantly. But are there ways in which technology might have damaged or harmed the development of architecture? We kind of refer to the laser cutter as the lazy cutter. Sometimes, you know, but it's a good tool that's sometimes misused. So that's kind of a silly small scale example. But on a larger scale, the ways that technology has hurt architecture.
I told you there's no bad dogs. There's only bad owners actually making bad dogs. Technology is in my point of view, is neutral. It's like you can use laser cutter making a beautiful physical model only made by laser cutters, or you can actually using as a lazy 3D cutter. You know, laser cutter as a lazy 3D cutter, actually you build up the walls like that. So it's depending on actually for you guys how to use it. And isn't it?
Maybe on a larger scale, not just school, but like...
Yeah, larger scales.
Well, maybe it starts to hurt when you have people using these tools that maybe fully haven't either been trained or fully understand the machine's capability. And because they haven't studied it, they think that the machine can virtually do anything. Especially, you know, and you guys, to evaluate you on your laser cutter use, I mean, you guys all know that 90% of what you cut, you can easily cut by hand in the wood shop. I mean, you're not cutting models, you're printing models. I mean, you're not actually like exploring the full sort of potential that these machines have. And I think it's just a bit of maybe lack of exposure to actually using it yourself. I mean, because that's how I learned the capabilities, was me working hands-on with it. I think if you're not around it enough, really looking at it, using it, exploring with it, you know, putting different materials in it, questioning the machine, then it gets underutilized.
I think that technology in general, of course, is never perfect. It's only tools, right? So we expect maybe a bit too much from it. The way how we operate is, we use as humans. So I mean, there's the first kind of failure, and then of course we are in a process where the whole strategy from design to fabrication to manufacturing to assembly is not yet completely thought through. Probably we are working on it right now. Yeah. And let me answer maybe also to Xavier's question from before. I think there is a huge difference between the high-tech architecture of the 80s, let's say, right? Because that was, in my opinion, maybe still a kind of a modernist point of view, which means you create this kind of aesthetically well-crafted object and you place it into an urbscape. Yeah. And it's basically sufficient by itself. And I believe what the change right now happens is, since we deal so much more with information, not only in architecture but across the sciences, that first brings us all much more together. Yeah? And then I think that not only because we are now also in the US very much thinking about sustainability, but also because the green part that is possible within architecture is only possible because we have those, to some extent, really technological tools, which means it allows us actually to be much more close to understand nature, yeah? And we can actually integrate nature to a much larger extent. It is no more, I think, only a metaphorical basis as we saw maybe in the 1920s with Gaudi. Yeah? Also, he was probably one of the most sophisticated architects anyway, because he understood at that time already how to use roof surfaces on a building in the most feasible and economical way. So he understood geometry, but today it is actually possible to go much more beyond that. Yeah, it's no more only geometry that we actually can tackle with because we have those tools. Now what we can do is we can actually question materials. Yeah? It is no more the stainless steel of the British high-tech architecture that we can actually put on a building, but now we almost think we are at the level that we can create interactive materials. Yeah? We can create materials, and some of them exist already. Yeah? They react to light, they react to wind, they react to anything that is sensor-driven. Yeah? Cohn Park is teaching courses where students experiment with that interactivity to some extent, right? And you can easily extend that into materials. So we are actually at the level where we can design building skins that are capable of a lot more things than just keeping the rain out. Yeah? They can become much more sensitive to our own needs from the outside and from the inside. And that is all information driven. It's just 1 or 0, depending how you program it. When we learn right now programming and scripting, it's because we start to play with a kind of material substance which is at the base of everything that actually surrounds us. Right? When you as students start to learn to program, then you do nothing else than a chemist that programs a chemical reaction. Right? You students right now, you learn to deal with the fundamentals of how design, maybe tools are actually made. Right? Just think about 10 years ago when we had 3D modeling programs, right? We were all very happy and thought, oh fancy, now I can almost design any shape. But the tools we used, they were nothing but they were programmed by people that were not architects. Yeah? They might have been aircraft engineers. Yeah? So we use tools almost still today which are not architectural tools. Right? Pre-programmed, pre-scripted tools where you go in and you have to click and you actually model and you do. You never questioned, right, why you do that. Now we are at the position where through programming and scripting, architects, they can design their own tools. Yeah? We are at the first moment in time at the level where we can say, now we can actually invent the tools we want. We can invent the tools that do what we would like to do, what we envision, yeah, that can be tailored to our qualities. And if you look right now on the market, the young emerging architectural firms start to design tools for large, big companies. Yeah? So big companies, 300 architects may be employed, they outsource computational geometry problems to small firms because they don't have the expertise. Yeah? And that's already one example. New professions are coming up right now because the young generation, that's you, takes a chance and tackles problems which other generations are unable to resolve. It's all based on information. The more you know about it, the more how you know how to deal and construct this kind of flavors of information, which are all digital, the more actually you will actually be prepared for the job out there. And I think that's the clear difference between 1980s architecture and today. So we can actually now control, in theory, every information possible dealing with architecture, from the materials to the design, to the fabrication, to the assembly. It's a big jump.
Well, the question, are we more obsessed about tools than architecture itself?
What?
Aren't we more obsessed about tools than architecture itself? Are we more excited about the tool itself than...
No, but we don't care about the tool. That's what I just said. The tool doesn't really matter because we make something that allows us to do something we want to do. Before we use tools, right, Exactly. Somebody designed tools for us. We use as architects. Yeah. A lot of those programs, Autodesk maybe in front. Yeah. You pull down menus and you design what you need to do. That's it. Nobody questions. Right. Now we are at a moment where, while we actually question and interrogate what information, how architecture is built in its information level, allows us to kind of completely revolutionize architecture. Yeah.
I'd like to put a context on this. How many of you are under 21? No, you're not, Josh.
Oh, you meant physically.
Okay, this gets back to Javier's observation just a minute ago. And what this whole conversation has gotten to, which is, I think, brilliant, is that epistemologically, we are located within the confluence of two main streams. The change in technology, our ability to actually command the way in which we conceptualize architecture, and at the same time, the economic paradigm with which we work. And the reason why I said 21 is because Javier made the I think, quite accurate observation that some of the words that we use to describe where we think we're going conceptually actually started about 21 years ago. Now, that's a time when those of you who were born at that time, or since then, you are actually around the corner. And the interesting thing to me about that is that corner goes back several thousand years. Because economically, architecture has always been driven, until 21 years ago, architecture was driven by a prevailing economic paradigm. That you make the same piece the same in order to make the building fit within the dominant economic paradigm that has governed architecture since Ictinus and Callicrates to 21 years ago. Now, what does that change? The change is that we can now make two pieces of a building which are slightly different with no economic penalty. That's a new paradigm. And if you think about it, what that means is that the shape of a building is no longer specifically an orthogonal parallel piped. It can change from column to column and beam to beam without an economic penalty. Now, the other aspect of that, to return to the idea that this is a change epistemologically and to go now from the economic side, now let's flip over to the conceptual side. What that means is we are free to think about architecture in a more dynamic way. That's where the term fast comes in. It's not that we're trying to make buildings look like planes. And just to make now what am I talking about? It's like we hear biomimicry. We're not trying to make buildings look like a frog. We're trying to make buildings perform biologically in a way, which was just pointed out, like a frog. That's a huge difference. Now, if we coming back to the concept, or the word fast, we're not trying to make buildings be fast like an airplane. We're trying to make buildings in a way that is conceptually fast. And I don't mean necessarily in the production, although that's an important part of what we're talking about. I mean we're trying to make buildings that are conceived in a way that is immediately evolving, which is what Christian just was talking about. And then just as a step backwards to the conversation about high tech. High tech was the beginning of this kind of thinking, but we didn't have the conceptual tools, nor did we have the economic opportunity to actually think this way past 21 years ago. But we had an idea that it could happen. And actually, when it comes right down to it, high-tech buildings never really were high-tech. They're actually, as Christian pointed out, really low-tech. They're very expensive, handcrafted, and so forth. But what's beautiful about this, and I can say this from the point of view, because I'm back around the corner. And all of you who are 21 years and younger, you're around the corner. You don't realize it, but you actually walked around a corner that has that's several thousand years along that wall, just to stretch the building metaphor beyond its possibility. I think it's a wonderful time to be involved with architecture. It's the opportunities as has been presented here in ways of thinking, in ways of creating, ways of configuring architecture, just gigantic, and it's wonderful. So, thank you, guys.
One thing that I appreciate is the opening analogy of the terminal velocities. And what's interesting in my perspective of this, and this is just to be transparent, I'm not necessarily saying I'm correct, in some sense we are the cat, right? But in some sense, so are our clients and the communities and the cities that we design for, and the fact that as technology started to gain speed, it wasn't that it was going too fast, it's that the distance was so immediate that the cat couldn't adjust. And that's what we're talking about in this story, is the cat's ability to adjust to what's going on. And so I wonder if that is in some relation why we immediately entered the digital phase with CAD monkeys. It's we don't have a way to really think about these tools. Let's use the tools exactly like we used pens and pencils before, right? It's this distance that's short. And as we gain velocity, we're able to adjust. Like, then there's the floors where we can't adjust. So like the distance is too short, and so we splat. Before, the distance was too short, but it didn't matter because we weren't far enough away. And then there's the ability to adjust from that 7 to 10 floors, where we're falling farther, it's going faster, but we can twist our bodies and our tails opposite ways and land on our feet. And then there's that other threshold where it doesn't matter if you adjust. It's going so fast, you're a pancake. And I'm wondering if that's, because I've noticed something the past several years that I find a little troubling with architecture in reference to technology, is it seems like we've gone from CAD monkeys to surface junkies. We've gotten to the point where it's moving so fast, we don't think about the big picture so much anymore, and we focus in on the material and not the materiality, the wall and not what the wall does. And so I'm wondering how, as a culture, we quit fetishizing the pieces and we start to get back to talking about architecture as a bigger thing again.
I think to some extent we had talked before about information, yeah, so that's kind of somehow covered, and we talked about tools and maybe Renaissance and modernism. Speed is also related to time, and there was also a big jump if we consider that, right? Because at the time of the Industrial Revolution, time was linear, right? So you built a city according to zoning. So you divide the city, you have certain areas, there is residential, and here has to be manufacturing, and there is leisure, and there's the park, right? That was the paradigm for a long time. And where we are now, since we moved from the mechanical age to the electronic age, or from industrial age to information age, what is changing is that now the city has to be planned in a kind of multitasking way. It means when we think about time, our time is no more linear, because the clock in the factory doesn't exist anymore. Our clocks right now are maybe here on the hand. Mostly actually they're actually on our phones. So the single clock that we had in the factory multiplied actually onto every person, which means time right now is almost everywhere, right? Almost irrelevant, because right now what I can do is I can work at any time, I can have leisure at any time, I can kind of almost sleep at any time if I have a shift working, yeah? And I can do that anywhere. Yeah. So we completely changed the way how we as humans operate. Now, since we operate in that way so diverse, the city had to be planned differently. Our cities are still according to zoning, So each zone has a different building height, different building codes. They're still restricted to different areas, but we live differently, right? You particularly, right? I'm not sure. You will probably work at any time you want. You can go, when you're a student, you can sleep at any time you want, even in my class. you can have leisure at any time. The city is not like this. The city is still planned as you would be on a linear track. Right? Now, how do we perceive space? Probably still the same way. But time is a lot different. So I'm not sure so much. Speed is certainly an important part, but to me it seems almost more important that time is actually the major criteria that we didn't tackle yet. How do we actually organize on the large scale? That's what you meant, maybe, Josh. Right? What do we do on a large scale? How do things change? Yeah, I think they have to change because we changed. And nobody responded yet adequately. I don't have enough information how the big new Chinese towns built for millions of inhabitants, how they are planned. I know for sure that Grigotti, the architect that we got a little quote on our email, he was building a town in China. I'm not sure if he built it accordingly to new standards. I only understood there should be kind of Italian. So I would imagine he's 84 years old right now. It's probably built like other Italian towns. Right? So in this sense, the big firms are not operating to those standards yet. Yeah, but they are the big market players right now.
I think if you differentiate technology and tool, you might see things a little more clearly. Like technology is the foundations, how the tool is made. And then tool is a very specific one. And then tool, sometimes you're going into like a rabbit hole about, because the tool have a very, very specific way of doing certain things. You're going into that spectrum and then you somehow lost there. But if you're looking at the whole thing as more into the higher level, as how technology actually changing it, then you're not only, adjusting some envelope system, but you're going to see the whole thing better, right? And I think that also goes into maybe Javier's, Professor Gomez's question. There's a good kind of possibilities that tool can be contribute the architecture significantly. Not this one, but there is the digital project, which is the parametric tool, building information modeling tool developed in Gehry technology. Because when Frank Gehry started designing it, he drew in the papers and then making a lot of models. But there's no CAD tool, computer-aided design tool, actually making the surfaces. So he actually looking at the ship manufacturing plant and then how they ship manufacturing, making the curve walls and everything, and what kind of CAD system they are using it. And he find out there's a digital kind of CAD tool solely to the sheet metal manufacturers. Is called CATIA, and also the sheet metal manufacturers for the shipbuilding or airplane buildings. So Frank Gehry made his own kind of form to develop, change that CAD tool into the architectural design CAD software, and that becomes a digital project. And that actually opens up the possibilities. He can design a lot of curved surfaces and very complex geometries. So in that matter, technology was in the middle, and then the tool, which is a digital project, becomes a specific tool design and also make it possible for Frank Gehry design. But on the other hand, it also goes to Stefani's questions about is there bad things. The thing you can see from the right side, That's a 3D building printing machine. That's a horrible thing. Come on, guys. That's going to be happen? We're not sure, because USC, University of Southern California, actually they making prototypes, do that kind of stuff. They are making that machine for, not in actually in United States, but for the space, for the going into the moon or Mars, and then they actually send that machine and then building up certain habitats over there. It's quite sci-fi. And that one is just animation, but a couple of months ago, I saw actually the machine pouring the concrete into the slabs. So that's the one, that's the tool, technology goes wrong. And if that comes into your neighborhood, and your next door, average Joe think, oh, I can design a building and click, 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 and then building just something like that. Then that's the direction that we want to prevent. And that's the kind of speed. It gets too faster, we jump up from the 16th floor and land it flat.
Yeah, but that's only bad because it's printing something bad. That's an incredible thing, maybe, in the right hands.
No, I think the idea about that, that's the technology is using it. If you're going into the right side, right? That's the another 3D printing.
Yeah, you don't think that's cool?
Well, it's not about cool. It's about
it's amazing actually though, that we have this ability to print at that scale.
Yeah, but in some point we cannot control, really, because it gets too faster. If that motion comes out,
that's kind of what I'm talking to. It's like if we get so infatuated with the pieces, we lose the idea of the whole. And so if we think that great architecture is made 1 + 1 = 2, we're wrong. It's what happens after that. After we add this and add this and add this, it culminates in something greater than we could have anticipated. And if it becomes this plug and play kind of way of assembling things, frankly, that's scary. If it's always just what it was supposed to be and nothing more, then is it space? Is it architecture?
Yeah, I totally agree with George's interpretation. I think we're so fascinated about technology. We're so fascinated about the software that's available right now. Because of course, it's got a lot of potential. But we're forgetting what is the purpose for that. We're forgetting the core of the whole thing.
But that was my argument about the feedback, that there now is no feedback of meaning. And that's directly at the beginning question that I still haven't, I don't think has been answered at all. The assessment of the cast. Yeah, the meaning and the feedbacks of what sort of experiments are happening. I mean, it's like, okay, well, I kind of disagree with us on that. This thing is, it might be cool, but what the hell is it? And the capabilities that are available are dangerous. I mean, put Maya in all of these students' hands, and we're all in serious trouble. Because it's so easy to kind of adapt. But because of the speed and the efficiency of the creation of these things, you don't have time. I mean, it's almost like there's no time to even talk about the values of the outcome.
We visit the seminal schools of architecture, the Sayars, the EAs, the Barleys, and it's scary because they're producing the most beautiful images that you can ever imagine, the most beautiful models that you can never expected to be built with all these robots and with the 3D printer and whatever kind of technology. But then the discussions are empty. Discussions are just about how they produce that object, and what kind of media they use, what kind of technology they use. But aren't we forgetting the core of the whole thing, which is architecture itself? because of this fascination with technology?
No, I think it's fascination to tool is wrong. But fascination to technology, for me, it's my personal standpoint is I'm fine with that. But fascination to specific tools and fetishizing that, then that's wrong. It becomes limited into the certain capabilities. And what do you think about the digital project? Digital project, which Frank Gehry actually made his own CAD software to realize his building.
I think this experimentation with CATIA was fantastic because he's the one that started doing this. I mean, and the results are the Guggenheim machine.
Yeah, I think that's the good example of how technology becomes a really productive tool for the certain aspects of the architecture.
Well, I mean, CATIA is not a new technology. It was used to build helicopters. And he found it available for anything.
No, he found the CATIA because when he was thinking about how to carving the wall, there's no possibility they can actually CAD manufacture it. So he went to the ship manufacturing yard and then looking at what kind of software they were using it. And Frank Gehry actually made his own firm called Gehry Technology, and then hired computer softwares, computer programmers, and actually changed the CATIA into the digital project. So that's the kind of good direction of how we're using the technology to developing our new tools to realize certain buildings. And of course, there's bad examples.
Primary started that thanks to Richard Serra. So thanks to the group of artists and his ideas again, I think that we need to put attention on those moments as well. I think it shouldn't be because of Richard Serra and everyone be at all.
I kind of wanted to hit on what Eric's been talking about. Professor Park mentioned earlier about sort of the laser cutter, sort of trash in, trash out kind of deal. And Professor White was talking about how we don't fully understand these machines that we're using or these programs that we're using, so we can be kind of careless or reckless. And sort of with the idea of terminal velocity, I just wanted to bring it back and talk about sort of pedagogical learning. Because of this paradigm shift, are we sort of required now to reevaluate our pedagogies and adapt more to this paradigm, or do we need a paradigm shift in our actual pedagogical structure? Because this is, I mean, it feels like, as your mission is one of schools, I mean, all this stuff is being created, but we're doing it so fast, we're not reflecting on what we're doing. So the way that we teach, we now have to adapt to this paradigm shift.
Yeah, I think clearly we have to, because the architecture curriculum, in my opinion, worldwide is anchored in the 19th century. Because the way how we operate right now is that we do a project. No, actually, we do upfront research, we do the project, we dump the project, we go to the next step, and don't think about what we did before. And the office professional practice is the same way. Okay? Research, president, design, construction, project, dump it. New project, new environment, new site, new design, new choices, and you start again from the beginning. It's a flywheel. Yeah? And they always repeat the same mistakes. We never learn anything from before. Yeah? We don't take clues. We don't reflect critically of what we did before, and the same is in academia. We are anchored in an old methodology. Yeah? And what we probably have to do is, they are tools. You can see them negatively or positively. They are explorations. They carve out a new area of knowledge. And it will at one point maybe be positive and contribute or not, we don't know, but they're just tools. Doesn't really matter. But what the point is to kind of find in general, which research should we do? and it brings back to what I said before, the big question is innovation. Where can we be innovative? We can only be innovative if we did the right research. So what does it mean, architectural research? And how do we link architectural research between academia and industry, and academia and practice? Yeah? How can we find together a way that we can, what we learn here, bring the practice back and forth? I think that's, in my opinion, the big leap and the big challenge that we have to face. We have to know, what does it mean for us to do architectural research? What does it really mean? What are the skills for a student or for a faculty member to do the right architectural research, gain knowledge, reflect on it, and then put it into a process where it can be actually implemented across the board. Yeah. So I think you're right. I think in general, the paradigm shift and the kind of revolutionary changes didn't affect yet everything, and I think there will be more to come. Yeah, and you are part of that. You actually should be actively involved in that. You should actually make contributions because, as our dean had said before, you are a generation that's around the corner, right? You will understand maybe much quicker and much faster actually where the changes might appear, where problems are, where the whole system somehow has leaks. Yeah? And you might actually indicate that to us if you are smart and you are actually going with the whole development. I mean, we cannot stop it anyway. You can like the tools, you can like the technology, it will be there anyway. It was always criticized, or even before. And on the other hand, as we had said, problems have been before as well. If we read, for example, the situation of the Japanese metabolist scene, they were also complaining. Everything is fast, the society is changing, culture is changing, economy is changing, what do we do? Right? We architects were always confronted with that. Yeah, that's what Kuhn Park said before, history repeats itself. It was always fast for us, and we always had to develop means how to adapt to that. Yeah, and right now we are really at the point that the profession changes and education has to change. Yeah, because we need to, I mean, if we really look at the profession right now, where can actually new innovative steps come from? Where do we have a lot of time? We have time in academia, right? Here, we have time, you have time. So we should actually do the service, almost in a sense, of exploring visions and new ideas and bring that to the profession. And I think we are not here to educate you to perform how the profession works right now. We actually are here to educate you to perform into the profession how it will be tomorrow. Right? So if somebody, when you get out here and somebody says, you're not doing what you should do, then you should say, but I want to do what you even don't know yet. Right? This is your job. We don't educate you to get out there and drop into a position to do something that is actually from yesterday. Right? You should be a critical mind, getting out there and innovate in the profession, in the job that you get. Yeah? They give you a job and you should change it. This is actually, I think, what we should do, and I think we should start here. Right? I think it will be very difficult because you have to also imagine that we, as faculty, operate into a structure that is also fairly static. Right? We have to deal with older generations. You know, we are a younger generation, and we cannot from today to tomorrow change everything. It is also difficult for us to kind of do that. But it will be a gradual process where it needs a lot of work from our side to convince colleagues and other generations and say, there are opportunities, why don't we take those? Why don't we go there? Yeah, it's a long process, but I think you pointed in the right direction.
One of the things that's happening here, because I want to underscore something again, the kind of criticism that Josh and Javier have just brought up is, I think, essential to the dialogue in architecture today between new technology and new humanism. And we're going to talk about new humanism next semester, but my point is that the last great dialogue we had in architecture was between postmodernism and deconstruction. And that was 25 years ago. So I think it's quite a great, it's not about antagonism, it's about sorting out fundamental problems of the way in which architecture works in the world. And I really like the fact that both of these positions are present here right now. And it's how we work through that. I think that's the most exciting thing, and probably for the next decade.
So you have all been talking about how quickly everything's been changing and how fast technology's been moving and how it's growing exponentially and how much it's changed from your time. How long is my generation going to last then in the job world? Because you're talking about how new students need to be pushing and saying, no, do this, this is the new technology, but I'm learning the new technology, and if technology continues on the road it's continuing, how long am I going to be able to be, you know, current? You know, how am I going to get out there and 5 years later, all of a sudden everything I know is practically useless?
No, I don't think so. See, it's the same. You're in the same position that I am. It means I have to continually adapt myself. Right? When I started with architecture, I think I still was drawing by hand, but I was a generation we quickly moved onto the computer, and I have to continuously learn new skills myself. And this is not only us. Our society is built right now on continuing education. You can talk to a doctor, you can talk to a lawyer, you can talk to a craftsman. Everybody right now has to force himself to continually be educated with new skills, to continuously learn new things. I think our society changes in this way. Right? We are no more, as I said before, you have a linear time. It means from 8 to 5 I work, then I go have leisure, then I eat, I go to bed, and I have a new day. No, it's no more like this. Right? You have people right now, and also the economy changes. It means we have a lot of society. They cannot support themselves with one job alone. We have a lot of people who have 3 jobs in a day, right? So we can be asked actually to continuously learn in order to adapt to new situations. So as we do right now already, and you might already do right now, you will do later on. If you don't do that, then you're right, you will probably lose your job. But only if we continuously learn, right? I mean, that's pretty known, right? We have to learn and learn, and there's no way. We cannot stop anymore. And it will maybe go faster. And I think you are the generation, because you deal with tools and technology much more intuitively, and you have a much larger or greater sensitivity to how you go about it. It will be much easier for you to do that than for us. Right? That we are kind of at least myself, an older generation. Yeah? For you it will be much more easier, but you have a continuously stream of new learning.
How did you got a new cell phone like last year, or the past 2 years? Or how many phones have you had? Like, you had to relearn how to use it, even with the new iPhones. Like, iPhone keeps introducing something that you're like, how am I supposed to keep up with this? But that's really what Christian is saying, is it's our generation's sort of niche to adjust and adapt and fit into technology as it comes about.
But you also have to consider, like, looking now, I feel like colleges are the ones that are introducing all this new technology to architecture. It's taking firms a lot longer to adapt to it. Is that going to continue, or is it going to become, they're picking up just as quickly as colleges are, and so therefore we won't have that time period to learn to be these new architects coming in every 2 years or whatever, and then the old ones are being left out. Because right now I feel like it's colleges that are the ones that are pushing the technology, while firms aren't necessarily keeping up as quickly.
That's not actually true.
False. I think there's a lot of firms out there that are actually pushing it quite a lot, and where we're trying to keep up. I mean, look at some of the top firms right now in the world. I mean, someone like Zaha Hadid or something, who has an insane amount of buildings that she has to build. So they're continually seeking out processes to build buildings at a more rapid speed. Like, how can they, pump this stuff out faster, because they have maybe insane deadlines they have to meet. So I think there's a lot of things that are generating in the office.
It's the industries that are pushing it, not the academics.
The academics are following. Which might make you more scared than what you previously believed, right? Because now you realize you're not on the cutting edge. The firms are already ahead of what we're teaching you. But that's okay. You'll catch up.
I want to say, I would agree with the industry pushing it, especially, I'm still here in here as well. If you look at the engineer side, there's a gap as well between the consulting engineer who's in a process and the structural engineer who's in a simplified process. Because if you look at Zaha Hadid and his precedent in her early works, a lot of the work was made by consulting engineers to create really innovative, structural systems to create these things. And the older engineers, the older generations will say, well, we don't know how to do this, so you send it to consulting brought it back to the old engineers, and they dumbed it down. So there's a gap also between what can be built, in both sides. You have older architects who know how to apply things. Like you have Zaha Hadid, John Paul, these are 56 years old, but it's not just the technology that makes it work great, it's the application. So even if you do get outrun by technology, you can technically do like Anvil. Anvil uses something really simplified, but he still creates great work. It doesn't take, you don't have to be the best parametric designer to create great architecture because it brings it back to a simplified level when it's all about the space. And it's not about the form that he has here. So that's all I need is more CCAP in the layer. So I think to answer your question, it's really not about trying to keep up with technology. It's trying to figure out a way to apply technology, whether it's simple or advanced, to create a certain effect or spatial quality in your architecture that makes it great.
It might be also about making the technology, let's say, more adapt or more, how to say, making the that's technology here. Making the technology more intuitive for us, right? I think personally myself, I don't like all the tools that I'm using because the way how they're done. Yeah? And I compared a bit maybe to the situation between a PC and a Mac, right? Maybe both operate very well, but the interface of the Mac was just always designed, while the interface of the PC is actually like more a work machine, right? And I think in a similar way, I would expect that the tools that we're using in the future and the technology becomes much more, almost surface intuitive, right? Maybe we don't need a mouse anymore to draw. Maybe the things become for us much more easier. That's what I would really kind of expect somewhere down the road. I think that to now, at the moment, it's not very customized to our way of working. I think that's actually a big problem. That's why maybe I would really somewhere also like not to have those tools around. And maybe going back to what you said before about meaning, I think there is so much exploration going on in a certain sense, and a lot of architects situate themselves in certain areas of research or design right now. And there's so much still to do that you might be right. Maybe sometimes the big overview is maybe still missing. And in fact, we have to say there is not yet a book written out there that actually summarizes the overall explorations and achievements of digital technology and architecture in the last 15 to 20 years, right? Actually, nobody could really grasp yet where we are and where we will go, right? So it's, even for us, it's still, I think, very hard to get the full picture right now.
Okay, I want to go back to what Josh said about bigger picture versus little picture. And I want to portray this because it's barely making sense in my head, but I'm actually a scientist more than an architect. She's an architect, but if you think back to the beginning of science, really, around just the beginning concept of the bigger picture is evolution like Charles Darwin. I mean, whenever he first came up with the idea of looking at that on the smallest scale of finches, which was at that point very revolutionary, you had to look at those really tiny details to ever portray such a huge picture. And you probably didn't even realize it back then. Whenever they had to come up with the ideas, even that they're still coming up with, on the very smallest scale, the point is that they're portraying such a big thought to humanity that it has to be understood on the smallest scale, even by that person. Like, you have to look at animals on the cellular level to points that we can't even see yet on a microscope. And the stuff they're coming up with now is trying to, like, from what I can tell, is these machines that are working within structures that we might not even be able to see right now, looking through the chemistry of it even, to concrete and steel and what you guys work with. And the machines can understand that, and even that machine that was like moving about, I mean, that, like, at first it does seem really scary. It's an entirely new concept. It's something that defies what we've been working toward, is turning ideas and manually constructing that with human that constructed the idea. But if that machine can conquer, if it can go to the top of a building, which whenever I see construction workers, it's amazing that they're up there. I mean, they could fall and die, but machines can't really die. They can go up there and they can look at that on a huge scale, even do things up above buildings, because whenever I see the top of buildings, its roofs, it's mostly flat these days from what I can tell, or that one right there where it's kind of curved. This machine could go to the top of buildings and reconstruct them into the bigger picture, even if we can't see it right now. And yes, that was, and also if you look at the Bible, even like going the opposite spectrum, they still debate if the translations are wrong. They debate everything within the small scale to see the bigger scale, if that makes sense.
Yeah, I think that you put a good point out there. Probably the next revolution in architecture is because of the nanotechnology, right? So the way how materials, and I think I had said it before, the way how materials will change or are changing, and the way how the architect, hopefully, right now not really yet, the way how the architect will have influence or collaborates with material scientists, that will probably very much change the way how we conceive buildings and maybe how we make meaning of buildings, right? Because buildings might have their own life at one point. Yeah? And you have, in a sense, when you look at it, for example, look at carbon nanotubes, right? Carbon nanotubes on the original scale, when they aggregate, you know what they do? They make architecture. They aggregate in a way that it becomes architectural. So what my opinion is, we probably at one point can design on a nano level, us as designers, materials collaborating with material scientists, because the way how those small molecules, and you refer very well to Darwin, the way how they aggregate in space. They create structures, they create patterns, they create new concepts, and I think we probably need architects at one point that help out there. Like the same way in the, for example, in spatial environments on the internet, they were for a long part designed by graphic designers, artists, anything, and the architect was left out. Look at Second Life, right? So I think that we can diversify in that sense and actually create new niches where we can operate and probably push at the same time the profession. Yeah.
Okay, well, I guess we'll bring this to a conclusion, and we want to thank you so much, everybody in the audience, for coming here and participating, and also to our panelists, thank you so much for coming and talking about this.